Hi, hello, welcome back to my YouTube channel. In this video, we are going to see about heat load calculation. First, what's mean by heat load? Heat load calculation is refers to the process of determining a heat load for a certain space or quality of matter. Heat load is the amount of heat energy that need to be added to maintain a desired temperature set point. It is also referred to as a heating load or a thermal load. Basically, heat load calculation is nothing but how much heat load is required at a set point of a temperature. Is known as heat load calculation. Let us look at the formula of heat load calculation. Q is referred as a heat load, and M is referred as a mass flow rate, and Cp is referred as a specific heat, and delta T is required as a change in temperature. So the final formula is Q is equal to M into Cp into delta T. For example, let us take a problem of a heat load. We have a cylindrical vessel containing 500 liters of water. And the vessel contains a specific heat capacity of 4.18 kilojoule per kg. The initial temperature of a liquid is 20 degrees Celsius, and you want to heat it to 80 degrees Celsius. The emitted temperature is 25 degrees Celsius. Calculate the heat load required to achieve the temperature increases. First, we determine the mass of a liquid in the vessel. So first we are calculating the mass of a fluid is equal to density into volume. So the density of water is 1000 kg per meter cube, and the volume that we convert into a meter cube, so 0.5 meter cube. So we multiply it, we get mass is equal to 500 kg. Now we get the mass. Now we have to calculate the changing temperature. So the temperature change is equal to final temperature minus initial temperature. So 80 minus 20 is equal to 60 degrees Celsius. So the final temperature change is 60 degrees Celsius. Now let us calculate the heat load, which refers the letter Q. The heat load Q is equal to M into Cp into delta T. So Q is equal to, we have find the mass of which is of 500 kg, and we have a specific heat which is given at the question. Specific heat of water is 4.18 kilojoule per kg, and we have a delta T, a temperature change is equal to 60 degrees Celsius. If we multiply three of this, we get 125,580 kilojoule. And this is a final heat load that required for this problem is 125,580 kilojoule. Now we have to calculate the time required to handle the heat load. So for the time is equal to Q by P. Q is referred as a heat load, and P is referred as power. So normally they use 10 kilovolt. So now temperature temperature is equal to Q by P. So Q is 125,580 kilojoules by 10 kilowatt. If we divide that, we get a time is 12,558 seconds. Within the time, within that heat load, we will get 80 degrees Celsius temperature will be reached at this time. And our final conclusion of this problem is we have a cylindrical vessel that contains 500 liters of water. So that water that contains 20 degrees Celsius, which is our initial temperature, we need a final temperature which is up to 80 degrees Celsius. So we got the heat load, which is 125,580 kilojoules. And we got the time, which is 12,558 seconds. So, within the time, we can reach 80 degrees Celsius. So actually, heat load is used to calculate how much heat load that required for the process, and it also calculates the time that required. And that's all about heat load calculation. We see an example problem. We'll see you in the another video. Thanks for watching.